Hello guys, welcome back to my YouTube channel. Today I am going to solve day 8 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today I am going to solve problem number 523, continuous subarray sum. Okay, so in this problem we have given an integer array nums and an integer k. Okay, so we have to return true if the nums has a good subarray or false otherwise. Okay, so what is good subarray? A good subarray is a subarray where its length is at least 2. Okay, so length should be greater than or equal to 2, and the sum of the elements of subarray is a multiple of k. Okay, that simply means that whatever the sum that I am going to get, the modulus of this sum with k is going to be 0. Okay, is equal to 0. Okay, so good subarray is a subarray where its length is at least 2 and the sum of the elements of the subarray is a multiple of k. Okay, note that a subarray is a contiguous part of the array. Okay, so it should be contiguous. Okay, and integer x is a multiple of k if there exists an integer n such that x is equal to n multiple k. Okay, and 0 is always a multiple of k. Okay, so now let's understand this with example 1. Okay, so this is example 1, right? So here this 2 4. This 2 4 is a continuous subarray of size 2 whose elements sum up to 6. And what is 6 modulus 6? It's is equal to 0 only, right? 6 modulus 6, right? So that is why we are returning true here. And here see, this is contiguous as well. After 2 we are selecting 4. And see, in example 2, 23 plus 2 plus 6 plus 4 plus 7, right, is a continuous subarray of size 5 whose elements sum up to is 42, and 42 modulus of 6, what is the remainder that I am getting? 0 only, right? So that is why we are returning true, because 42 is a multiple of 6, right? 42 is equal to 7 into 6, right? So see here, x, let's say x is 42. 42 is equal to n is 7 into 6, right? So x is a multiple of k if there exists an integer n. Okay, so see, this condition is satisfied, right? 42 is a multiple of this 6, right? So that is why we are returning true here. And here in this example 3, you are not going to get any sum which is going to give you the remainder 0. Okay, so let's see, 23 modulus of 13. Okay, it is not going to give to 0 right now. But also one more thing, we need the length at least greater than equal to 2, right? So 23 plus 2 is 25, and 25 modulus of 13 if you do, then also you are not going to get the output, right? Correct output. It is going to give you 12, right? Then 23 plus 25 to 25, 25 plus 6, 31. 31 modulus of 13 is also not equal to 0, right? So you are not going to get any output here. Okay, you are not going to get any contiguous subarray where length is greater than equal to 2 and some modulus of k is equal to 0. That is why we are returning false. Okay, so now let's understand first beginner's approach, how we are going to solve this problem using a beginner's approach. Okay, but see here, in this problem constraints are very large. Okay, so my first approach definitely going to give you the time limit exceeded error. Okay, but let's understand first few basic things. Okay, so initially let's say this is my nums array, right? And initially my I is at this position and j is at this position, because I know that length should be greater than equal to 2. Okay, so let's say my I is at this position and j is at this position. Then first I do the sum of this 23 plus 2. What is the output that I am getting? 25. And what is 25 modulus of 6? Is it equal to 0? No, it is not equal to 0, but it is equal to 1. Okay, so now let's say my j moves forward. Okay, So now my j reaches at this position. Then what is the sum of this 23 plus 2 plus 4? It is going to be 29, right? 23 plus 12, 2, 25, 25 plus 4, 29. 29 modulus of 6 is also not equal to 0. Then my j is going to move forward. Okay, so let's say my j reaches at this position. Now what is the total sum that I am getting? 23 plus 2, 25, 29, 35, right? So 35 modulus of 6 is also not equal to 0. Okay, then my j moves forward. Okay, so now my j moves forward. So now my j reaches here. Okay, then what is the total sum that I am getting? 25 plus 4, 29, plus 6, 35, 35 plus 6, 35 plus 7 is 42. Okay, 35 plus 7 is 42, right? Okay, so 1 here, 42. Now see, 42 modulus of 6, 42 modulus of 6 is equal to 0, right? So this time we can return simply true, right? So output is true here. Okay, if we just do the sum of all these, right? Let's say this value is 8. Okay, then my total sum is going to be 43. Okay, then 43 mod of 6 is not going to be 0. Okay, so in that case, what is going to be my next thing? So here I am going to just move my I to the next pointer. Okay, I is here at initially, so now my I moves to this position and my j is going to start from here. Okay, this is going to be my next step. Okay, if in case 7 is not there but 8 is there. Okay, because for better understanding I am just changing the input here. Okay, so if it is 8, then my sum is not going to be definitely my sum is not going to be 42. Okay, if it is 8, it is going to be 43. Then 43 remainder 6 is equal to 1, right? So then my j is going to start from this position and I is going to move forward. Then from here I have to follow all the steps. 2, 4. Okay, now 2, 4 is going to give me the sum as sum 6, and 6 modulus of 6 is 0. So I have to return true. Okay, but this is going to be my approach. Okay, so first my I is going to be fixed here. Okay, so here I just want to tell you the approach. Okay, what is the beginner's approach? So I is fixed here, then I am moving j one by one. If I am getting sum and as remainder of k is equal to 0, then I am returning true. Then my I moves to next position, then j is starting from the here, right? Then my I moves here, then j is starting from this position to this position. Then my I start from here, then j. Okay, so this is the approach one. Okay, so I have already coded for approach one, but I am getting the time limit exceed error here. Okay, so with approach one, 94 out of 99 test cases has been passed, right? Okay, so this is the code. So initially I am getting the length. Okay, what is the length of my nums array? Then my I is equal to 0. Then I am running one while loop, and inside this while loop I am calling one helper method. Okay, and this helper method is going to return true whenever my sum modulus of k is going to be 0. Okay, so in this helper method, see, initially my sum is starting from the first index. Okay, whatever the number here, nums of start. Okay, whatever the index that I am passing here. Okay, then after that I is equal to start plus 1, because I am starting from next position. I is here, then next position is this one, j j j j, right? So here I am using one for loop here, and then whenever I am getting some modulus of k is equal to 0, I am returning true, otherwise I am returning false. Okay, so whenever in this while loop, if helper method returns true, then I'm good, but if it doesn't return anything in this while loop, then in the end I'm returning false. Okay, so this is going to be the beginner's approach. Okay, 94 out of 99 test cases passed. Okay, so now let's move to the approach 2. First thing here, let's say there is one number, let's say 17 is there. Okay, so when I do the modulus of 17 with 3, then tell me what is the result that I'm going to get. 17 modulus of 3, the result that I am going to get is 2, right? 17 modulus of 3 is equal to 2. Okay, now when I am going to add, let's say, any multiple of 3 in this 17, then what is the remainder that I am going to get? Okay, so here what I am saying here, 3 into 1 is 3. Okay, 3 into 2 is 6. 3 into 3 is 9. Okay, so now let me do one thing here. In 17, let me add this multiple. 6 is a multiple of 3 now. So if I add this 6 here in 17, then what is the result I am going to get? Tell me. 17 plus 6 is 18, 19, 20, 21, 22, 23. 23 modulus of 3, I am going to get 2, right? And if I add 9 in my this 17, and then I do the modulus of 3, modulus with 3, then what is the output that I'm going to get? So what is 17 plus 9? It is nothing but 26. 26 modulus of 3, I'm going to get 2 here. Okay, so see here, from here one thing is clear, that whenever I'm going to add multiple of k, okay, let's say this is my k, okay, so whenever I'm going to add the multiple of k in my number, and then do the modulus with k, I am always going to get the same remainder. Okay, so this is one basic math property. Okay, so I hope that you guys are clear with this, right? So whenever I am adding the multiple of k in my number and then do the modulus with k, and I am always going to get the same remainder. Okay, so I am going to use the same property here. Okay, for this example, let me pick this example number 1. So here what I am going to do here, so initially my nums array is like this: 23, 2, 4, 6, 7. Okay, so here I am also going to use one hash map. Okay, so here I am going to store remainders, and here I am going to store indexes, at which index I found this particular remainder. Okay, so let's do the indexing of this one. This is 0th index, 1, 2, 3 and 4, right? So here initially before starting, let's add one thing here. For 0th, if I get any remainder as 0, then I am putting that into my index, this one, -1. Okay, so now let's move forward. Okay, so here initially I put this in my map. Okay, the remainder is 0, then I am putting that in index -1. So initially my sum is equal to 0. So what I am going to do here, so here let's say I am at this position initially. Okay, so here I am going to do sum is equal to sum plus this number. So what is the total output that I am going to get? I am going to get 23. Okay, this is what I am going to get, 23. And then after that I am going to do the modulus of this 23 with the k. Okay, what is the value of k? K is 6, right? So 23 modulus of 6, what is the output that I am going to get? 5, right? 6 3 is 18, 19, 20, 21, 22, 23. Okay, 5 is the remainder. So I am adding this 5 here, and here at which index I have found this 5. So I have found this 5 at index 0. Okay, so I am adding this here 0. This is done. Then after that my I moves further. My I reaches at this position. Okay, so now here let's do the sum first. What is 23 plus 2? It is nothing but 25. Okay, so let me write it like this: 23 plus 2. Okay, modulus with 6. 23 plus 2 is 5. 25 plus mod of 6 is going to give me 1. Okay, so let's add 1 here, and at which index I have found this one? At 1 index only, right? This is done. Then what is the next number? Next number is 4. Okay, so now let me add it. 23. Now you will get one much clear idea. 23 plus 2 plus 4. Okay, this is a number. 2 plus 4 modulus with 6. Now see what is the output that I am going to get. 23 plus 2, 25. 25 plus 9, 25 plus 4, 29. 29 modulus of with 6 is going to give me 5. Yes, this 5 is already exist here in my map, right? This 5 is already there in my map. So now it is already there, right? Because this is my k. Let's say this is my k, this is my k, and this is my multiple of k, right? 2 plus 4 is nothing but 6. Yes, this is a multiple of my this k, right? 6 into 1 is 6, right? That is why I am getting the same remainder here. That is why I am getting the same remainder here. I have already explained this property now, right? So I am getting the same remainder here, right? Because this value is the multiple of k, right? So here this 5 is already there in my map. Now what I am going to check here, at which index I have found this 5. I have found this 5 at this index right now, at 2. My I was at this position now. Okay, so this is 2, and initially I have found 5 at this index 0. So 2 minus 0, what is the value that I am going to get? Here I am getting the 5 remainder, and here also I am getting the 5 remainder, right? 23, and here also. So right now my I is at this position. So what I am going to do here, I am going to subtract I minus map dot get remainder. So at which index this 5 was available? 0. Okay, so I is 2 right now, and when I'm doing subtracting 0 from 2, I'm getting the output as 2. Okay, yes. So what this 2 means? This 2 means that I am getting the subarray with the length greater than equal to 2, right? So this condition is required, right? And I am also getting the same remainder, right? So that is true. Okay, so this I am getting 2 here now. So see here, this is true. 2 minus 0 I did. So yes, I am getting one subarray. See this subarray 2 4, the length is greater than equal to 2, and sum of this one is also 0. 2 plus 4 is 6. 6 modulus of 6 is 0, right? Because here you guys are correct now, right? This is a multiple of my k, this number. So definitely when I am going to uh, do the modulus of 6, modulus with 6 of this whole number, I am getting the same remainder 5. Definitely I am going to get one subarray of length 2 here, whose modulus with this 6 is going to be give 0. Okay, so 2 plus 4, see here, this subarray length is greater than equal to 2, and 2 plus 4 is 6. 6 modulus 6 is 0. So that is my output. Okay, we have to return true in this case. Okay, so that's it. Now let's move to the coding part. Okay, so now first we need to create one hash map, right? Hash map, integer, map, new hash map. Now initially let's put 0th remainder at -1 index. Okay, now initially sum is equal to 0. Then after that we have to run one loop for int I is equal to 0, I is less than nums dot length I plus plus. Okay, then after that we have to add the sum is equal to sum plus nums of I. Then after that we have to calculate the remainder, int remainder is equal to sum modulus with k. This is my remainder. Then after that we have to check if my map dot contains key. Okay, which key? This remainder, if it is already there. If it is already there, then after that check one more thing, if the size should be greater than or equal to 2, right? If I minus map dot get remainder is greater than 1, then in that case we have to simply return true. Okay, code is very simple, right? Return true. And in the else part, if there is no key, if my map doesn't contain this key remainder, then I have to put that key in my map dot put remainder, and at which index it was I. Okay, this is the and in the end if I didn't find anything, then I have to return false. That's it. Now let's run the code. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And in this problem, time complexity is going to be of n, because we are iterating over all the elements in my nums array one by one, right? So time complexity is going to be of n, and since we are using a map here, so my space complexity is also going to be of n. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.